More Industries presents a temperature sensor technology demo with Peter Wielander.
One of the routine maintenance functions in a process plant is replacing temperature sensors from time to time. The sensors themselves are usually very durable, but sooner or later you're going to have to pull the element out of a thermal well and put in a new one. Here's a typical sensor element. It's encased in a rigid stainless steel housing that provides protection without slowing the response time excessively. Where circumstances are favorable, this is an excellent way to go. On the other hand, that rigidity is one of the biggest drawbacks. You must be able to push it straight into the thermal well, which means that you must have its length and more of free space. In most cases, you will need to remove the transmitter housing, which makes the replacement process all the more complicated. Disconnecting and remounting wiring is always an invitation for problems. If the probe is not the same length as the thermal well, you have to stock a custom length probe. To make matters worse, the thermal well has to be perfectly straight and free from any internal debris. Getting a fast response time requires that the sensor element is all the way down to the end of the thermal well and fills up the internal space as best as possible. If the thermal well is bent or if there's junk inside there, it's hard to push the element all the way in. If the element isn't all the way in, you'll get a temperature reading, but it may not reflect what you want from the process. More Industries has created a simple and effective solution: the worm. A worm provides protection for the sensor element and wiring, but it's flexible. Here's how it works. A typical worm kit includes everything you need to make conversion from a rigid-style temperature probe and to install it in nearly every new application. The basic worm probe includes a rigid tip, but the rest of the sensor is a flexible stainless steel spring. This serves three important functions. First, it protects the wiring, but it can still bend for easy insertion. Second, it can be cut to the ideal length for a given thermal well, allowing the spring to keep the probe tip pressed into the very end of the thermal well bore. You no longer have to stock a variety of lengths of sensors. The worm is one size fits all. Third, the amount of metal surrounding the sensor is reduced, so it doesn't take as long to reach the full process temperature. This means a worm has 13% faster response than a full sheath probe. So let's see how it works. The kit includes several different components that help with the back-end termination of the spring and spacers for use in larger diameter thermal wells. Let's go back to that first thermal well and transmitter housing we looked at. For purposes of demonstration, we've made the thermal well out of clear plastic. We want to insert a new probe without taking off the housing, which is no trouble for the worm. Simply insert the worm into the thermal well and push it all the way in. When the probe bottoms out, mark the spring about an inch or so beyond the housing, so the spring is a bit over length. Cut it carefully with a pair of wire cutters so you don't damage the signal wires. There's a cap in each kit that fits over the end of the spring where you cut it off. Put it in place and then attach this little spring clip with the prongs pointing toward the probe end. Now, when you reinsert the probe, use a pair of pliers to squeeze the prongs together and hook them into the transmitter opening. This will put pressure on the probe spring that will drive the tip all the way to the end of the thermal well. To remove the probe, just squeeze on the spring and pull it out. More Industries transmitter housings have a lip above the half-inch NPT threaded connection, and the spring clip will stay hooked there. Some generic housings do not have that lip, so there is nothing for the clip to hook onto. In those cases, you can press the rubber stopper in place to retain the spring. Each worm kit also includes the stopper. If the connection between the thermal well and housing is a section of half-inch pipe or heavy wall conduit with a full internal bore, these spacers will help keep the worm spring centered and ease insertion. Simply stack in as many as required to fill the space. The spacer's internal bore is large enough for the probe to pass through, so they can stay in place in the pipe. They're included in each kit and can also be purchased separately. If you have head mount enclosures, such as Moore's LH type enclosure, use the same procedure and cut the worm spring so it is an inch or inch and a half longer than the thermal well assembly. Place the ferrule cap over the end of the spring and replace the instrument transmitter in the enclosure. The transmitter will put pressure on the spring and hold it in place. If you're using a screw-in retainer bushing, compress the spring and screw the bushing in place. This will keep the probe tip in direct contact with the thermal well bottom. If it's too hard to compress the spring, simply cut a little more off. Now that you know some of the mechanics of using worms, think about where they might be handy in your process. Let's say, for example, you want to get a temperature reading from some point where you haven't been able to do it before because, putting it in is going to require a thermal well that looks like this. Now, you're never going to get a straight temperature sensor into that, but, a worm goes right on in. If you have thermal wells that have suffered damage or corrosion, the worm will help you because it's only 237 thousandths of an inch in diameter. It's hard to see the difference, but this helps it slip into those tight thermal wells where a full 250 thousandths probe may be just a little too tight. Additionally, if you have long thermal wells like this that might be bent or sagging, you can no longer easily get a straight sensor in there, the worm will help you, and it will save you having to replace the entire thermal well. In addition to solving maintenance headaches, worms can save you in your stockroom as well because you don't have to keep specific lengths. One size here, either in 24 or 36 inches, can be adapted to any number of thermal wells, and you only have to keep one stock item. Worms are available in quite a range of sensor types too. If you need thermocouples, there's a selection with types J and K being the most popular. Choose from standard and high temperature versions, both grounded and ungrounded. If you prefer RTDs, choose from 100 or 1000 ohm, standard and high temperature platinum, copper, and nickel. You can even get vibration-proof and waterproof designs if your process demands it. Once you're convinced, you can save even more by buying a whole can of worms, 10 units, and save 30% over single unit pricing. More Industries makes a whole range of products for process applications for signal interfacing, temperature measurement, networking, alarming, and field bus networking. You can see them all at More Industries' website, www.miinet.com. Again, More Industries, www.miinet.com. This is Peter Wielander. Thanks for watching.
Copyright 2010, More Industries International, Incorporated.